My name is Ivan. I'm from Wallarm company, and we working in security, information security area, in part of application security. But sometimes we need to relax and do something really cool, such as IoT hacking. And my short presentation about IoT device hacking and about practice, about vulnerabilities, and also about taxonomy of security. So, what I'm about, just research only household appliances such as multi-cooker teapots and other, not about IoT in area of car, vehicles and other. Just about only Wi-Fi only devices, not as Zigbee and others communication ways, not about Bluetooth device and other. And my talk only about end customer devices. For example, not about cloud security, not about other aspects of IoT security. We analyzed 5 devices from 3 different vendors. So before vulnerabilities, I want to talk about 2 different ways to produce this kind of devices, IoT devices. First is I call it Chinese way. Chinese guys take any device, for example, a multi-cooker, for example, teapot or other device, and find serial port, just a connection way between buttons and display, and then connect special Wi-Fi to serial main board module to serial port and profit, because at this stage Chinese guys got a really working device, any household device with Wi-Fi. And the second way is a Belkin way, I think US way, takes any existing device such as Wi-Fi router and make something with black magic and do profit also. And therefore, when we deals with Chinese device, we deals with free RTOC operation system, and in US cases, we deals with Linux devices. And this is really great difference between to this kind of devices. So the first stage of device connection is the connect stage, when device came as access point and endpoint user want to connect a new IoT device to exists wireless network. At this stage, very important to obvious security things. It's encryption and credentials, which may be default, and also vendors must make sure that communication configuration interface disabled after initial setups. I think it's obviously cases, but also such devices have a magic way to connection. It looks like at first stage you enter your Wi-Fi SSID and password to mobile application, for example, for iPhone or for Android app, and just press enter and profit. That's all. At this stage, really hard to understand at first time what happens, but endpoint and a user device, IoT device, retrieve this SSID and password and connects to this wireless network. Inside this process, it looks 5 stages. First stage, your device, your iPhone or your Android, combine SSID and password to SP packet and try to find a network with this SSID. And of course, it's API call from all operation systems such as iOS or Android, and it's legitimate operation to find a wireless network with any SSID. But these guys use this ability to transmit SSID and password from any mobile device to IoT devices. And after that, IoT device catch this broadcast packet and decode SSID to SSID and password and store it and connect just in really magic way. And at this stage, of course, it's only one-time operation, but at this stage, any VAR driver, any wireless attacker can catch as an IoT device's broadcast packet and decode SSID and password. This connection way have a special name, but I can't remember it now. So just some about backdoor stories. We found a nice backdoor in Chinese device, which consists of hard-coded IP address, using as really common line tools such as strings or the compilation process to retrieve IP address from firmware, and then try to understand for what these guys had coded IP address into firmware, and found that this address using as an NTP service, and this really nice idea because NTP service it's a legitimate protocol for all firewalls, and many devices use NTP protocol to synchronization times clocks. So basically, this backdoor provides to vendor ability to count all devices remotely, because all devices send the packets to a remote host. But also, if we try to research this firmware in details, we can find a memory corruption vulnerability in response passing function, and for that, vendor which can control this remote host in China can also make special crafted response to NTP client and exploit this end device as this vendor want. So just really nice backdoor, and really hard to understand what happens when you try to analyze only TCP dumps, for example, because this operates only with valid NTP requests, and the NTP response with a payload can be so just about vulnerabilities. First vulnerability which I must to talk is a vulnerability in embedded web server in one Chinese device, and this vulnerability is really really easy to understand. When we connect to this device and want to get some administration functions such as administration panel, visit administration panel, this device asked us a password and login, and sent a valid response, but after that sent also a second response with content of administration panel. Just a state bug in web server coded for free R2C operation system, and if you use a ordinary browser, you have no chance to find that. But if you use, for example, TCP dump or Telnet, as shown in the slide, you can find this vulnerability and find a lot of fun. So, second vulnerability is vulnerability in one US vendor, it's Belkin vendor, and I still doesn't allow to publish details of this vulnerability because I received this email from Belkin Product Security today. But I must told this that just was a nice vulnerability, and this vulnerability I think must have 10 CVSS score. This is removed code execution vulnerability with root privileges, as you can see this slide is valid etc shadow from power supply. So it's nice. So, and another one vulnerability found it again in Chinese device, and this vulnerability nice because we can send a valid JSON packet, and this socket port only operates with only valid JSON packets, and it's not legitimate to send HTTP requests to this service, but the service path also HTTP requests, and for that we can try to exploit the service as a server-side, as a client-side request forgery, and put this link to, for example, a blog, for example, to other public resource, and when our target user visits this page, his TE port turned on. Just really nice because by design this network service doesn't allow any HTTP requests, only JSON-based protocol such as JSON RPC for raw sockets. So we try to produce a taxonomy of attacks and the taxonomy of vulnerabilities, IoT devices, and also try to classify various attackers by attack ways. First group, it's a website external from internet attackers which use in server-side, client-side request forgery or vulnerabilities like this. Second is Wi-Fi goosed. It's warp drivers and other guys. I thought a neighbor, it's your guys without your Wi-Fi password, and there's a difference between Wi-Fi goosed and neighbor, that Wi-Fi goosed have their valid password from your wireless network, home wireless network, of course. And the next group is a vendor which can put backdoors in firmware, and the last group is a retailer and delivery companies and others which can try to modify firmware after manufacturing before this endpoint and customer device came to customer. So I think the most important slide for my presentation is this slide, and also put it to the OWASP chapter as a IoT security checklist. And this is in one table presentation all attackers models, and also different checkpoints such as unprotected wireless access, authentication, encryption, authentication for firmware update, firmware integrity controls, backdoors and hidden exchange services, client-side vulnerabilities, server-side, and physical protection from damage, with different metrics in the third column. We try to produce a way to compare levels of security of different IoT devices, different vendors, and different IoT devices. Of course, just not covered all aspects of IoT security, such as cloud security, such as mobile application, mobile client security, which used to communicate with IoT and other. But we try to cover end customer device security aspects and produce this checklist to make security audit process easier. So our stats: we analyzed 5 devices and hacked all of them, and found 3 backdoors. Found 3 backdoors in 5 devices, and also have no any ideas to deal a physical damage to devices, for example, explode this or do something like that, because all analyzed end customer devices has a physical level protection, such as relay and other built-in physical protection mechanism. So I think that's all. If you have any question, I can answer.